Hello everyone, I am Shupatra Pancha, Assistant Professor, Department of Computer Science and Engineering, PhD is VP Dr. PG Harkatti College of Engineering and Technology, Jaipur. So in the last class, we have discussed something about random number generation, some concepts of random number generation. So in this, we'll be discussing the basics of randomness, some of the factors of random numbers, and also something about information hiding. So we'll go for the random. So let us define what is exactly the random. True random is hard to define. Entropy is a measure of randomness. So entropy is a factor, so which is actually a measure of randomness generation. Good sources of true randomness. Radioactive decay, but radioactive computers are not too popular. Hardware devices, many good ones on the market. So lava lamp relies on chaotic behavior. So these are some of the sources of randomness. So exactly about randomness, source of randomness via software. Software is supposed to be deterministic, so must rely on external random events, mouse movements, keyboard dynamics, network activity, etc. So can get quality random bits by such methods, but quality of bits is very limited. The bottom line, the use of pseudo-random processes to generate secret quantities can result in pseudo-security. So that's what the importance of randomness. So next comes about information hiding. So before going to discuss something about this information hiding, what is exactly that information hiding? I think in the previous class I had discussed something about visual cryptography, and in that visual cryptography, what happens if particular authorized users wants to share some information, and such users are going to add their shares that is visible to the public, that is visible to the other users. But here, this information hiding is not like that. So we'll be sharing the original information by hiding some important information, but actually it is not hidden. So that is what we can call it as the information hiding. So information hiding, in that information hiding, will there are different types. One is digital watermarks. So again, in digital watermarks, there are two types. One is visible and another one is invisible. So digital watermarks example, add invisible information to data. So defense against music or software piracy. So in such music or software piracy, there is some data which is added in that which is invisible. That is what we can call it as the digital watermarks. And one more is what I can call it as steganography. So in this steganography, what we have is we can call this is also a secret communication channel, similar to a covert channel. More later, example in this is data is going to be hidden in such particular file. So one example is hide data in an image file. So of course there is a difference between digital watermarks and steganography. In digital watermarks, data is not hidden, but some extra information is added to the original image which is not visible. But in steganography, what happens? Here also the message will be transferred, information will be transferred in secret way, but some part of the data will be hidden and sent it to the authorized user. Hide data in an image file. So watermark. What is that exactly a watermark? Add a mark to a data. It's very simple. And there are two things. One is visibility or not. Visibility of watermarks. Invisible. Watermark is not obvious. Of course, watermark will be there, but it is invisible. Visible, such as top secret. The watermark will be visible, but cannot be recovered the original data from that visible watermark. Two types in visible watermarks. And second one is strength or not of watermarks, so which is robust, readable even if attacked, fragile, damaged if attacked. So two things. One is based on the visibility, invisible or visible, based on the strength, robust or fragile. Robust is what? Readable even if attacked. Fragile is what? that particular information is totally damaged if it is attacked. So this is what something about watermark. Watermark examples: add robust invisible mark to a digital music. This is one example. If pirated music appears on internet, can trace it back to original source of the leak. But it is actually what you can't add visible watermark to such examples. So you are supposed to go for invisible. Add fragile invisible mark to audio file. If watermark is unreadable, recipient knows that audio has been tampered with integrity. Some source of information, some of the hacker have uh, read a particular. Some of the hacker have identified the integrity or but broken the particular audio file. So this is what we can call as a fragile invisible. So robust invisible, fragile invisible. In robust invisible mark, even if a particular attacker hacks the music, then also at the receiver end, receiver or original receiver can uh, listen to that particular music. If it is fragile invisible, it is totally undetected. Combinations of several types are sometimes used. Visual plus robust invisible watermark, that is also possible. Both can be combined. Robust as well as fragile invisible watermark. One more, that is a non-digital watermark. Best example is there may be a currency, right? One example is US currency. So here in this, some watermark is added. Image embedded in paper on RHS hold will light to see embedded information. So some information is added in this particular non-digital watermark. It's not digital; it is a physical one. So, but even if it is physical, watermark is added to avoid uh, original currency, right? To there is a case that fake currencies are in the market. So one more example is add invisible watermark to photo. Claim is that one contains 1 inch per square contains enough information to reconstruct entire photo. If photo is damaged, watermark can be used to reconstruct it. So that's what invisible watermark to photo. So according to Herodotus, Greece 440 BC, this is something else, an event. So saved slave's head, wrote message on head, let hair grow back, sent slave to deliver message, save slaves had to expose a message warning of Persian invasion. Historically, steganography used by military more often than cryptography. So finally, steganography is what? Information hiding, hiding of information. Images. So how steganography can be used combinedly with images? So usually what happens? Images use 24 bits for color, that is RGB. So R takes 8 bits, green takes 8 bits, and blue takes 8 bits. So it's a color components RGB. For example, one example we have used is, see, this is RGB. So is this color, and one more is this particular color. So what happened? While we have one more color here, you can see this. So lower order bits don't matter. So we need to combine. We need to hide the information in the color images itself. Images and Chago. Given an uncompressed image file, for example, BMP format, we can insert information into lower order RGB bits. So that's what we have discussed in the previous slide. Since low order RGB bits don't matter, changes will be invisible to human eye, but computer program can see the bits. There is one more Stego example here. You can see this. Uh, this is what Alice image. Left side plain Alice image. So there is it doesn't contain anything. It's original image only. Right side, right side also it is a Alice image only, but it contains some information, some hidden information. How exactly? Right side Alice with entire Alice in the Wonderland. So this is a PDF. It's a book hidden in the this particular original Alice image. So Alice with entire Alice in the Wonderland. It's a PDF. It's a book content hidden in the image. But what you can see in this particular slide is both are same. You can't differentiate both the images here. But in that right side contains a PDF book, but left side doesn't contain anything. It is original image as it is. So that's what the concept of steganography is very important. So this is what non-stego examples. So you can see this wireless.html in web browser. So here also we can add some information. We can add some information that is hidden. The time has come. We wireless said to talk of many things. So this is a text information. What we are going to say is this information is also contains some hidden information. That is what stego example. So hidden message, what we are going to send here is something else in the form of bits 011, 010, 100 like that. So with many bits here, which contains this particular text information. So finally, some of the points about steganography. Some formats are more difficult than HTML for humans to read, but easy for computer programs to read. Easy to hide information in unimportant bits. Easy to damage information in unimportant bits. To be robust, must use important bits, but stored information must not damage data. Collision attacks are also a concern. Robust steganography is tricky. So this is something about steganography. So with this, we have completed the second module. So now in the next class, we'll be starting the third module. Thank you.